In the 1770s, people relied on crumbs of bread to remove pencil marks. Bread left smudges, tore paper, and spoiled quickly, yet it remained a common tool. That changed when a simple mistake revealed a better option. An English scientist named Joseph Priestley handled various materials during his experiments, including small pieces of natural rubber, known at the time as caoutchouc. Rubber reached Europe from South America and remained costly, rare, and strange to most people. Its elasticity and sticky surface fascinated researchers, but its practical uses were still mostly unknown. One day, Priestley accidentally dropped a piece of rubber onto a sheet of paper covered in pencil marks. When he lifted it, he noticed that the graphite marks had disappeared precisely where the rubber touched the page. The material removed the pencil markings more cleanly than bread ever had. The accident revealed a completely new use for rubber. Priestley documented his finding, and rubber pieces began to be shaped and sold as rubbers, even though the material itself still had major problems. One persistent issue was that natural rubber deteriorated easily. It melted in the heat, hardened in the cold, and crumbled with time. Users complained that rubbers smelled awful and sometimes stuck to the pages they were supposed to clean. For decades, these issues limited the wider use of rubber products. In the early 19th century, a breakthrough emerged from an unexpected accident involving a struggling American inventor named Charles Goodyear. Goodyear experimented obsessively with improving rubber's stability. During one attempt, he accidentally dropped a rubber mixture containing sulfur onto a hot stove. Instead of melting into a sticky mess, the heated mixture transformed into a tougher, more durable, and flexible material. This reaction later became known as vulcanization. Vulcanized rubber resisted temperature changes, remained elastic, and no longer rotted or crumbled the way untreated rubber did. This new stability solved every major weakness that early rubbers faced. Once vulcanized rubber became available, erasers finally reached their true potential. They could be produced consistently, shaped easily, stored for long periods, and used without crumbling or smearing. By the mid-1800s, erasers became common tools in schools, offices, and drafting rooms. As pencils improved and mass production increased, the demand for durable erasers grew rapidly. They appeared on pencils, in standalone blocks, and eventually in precision forms such as kneaded erasers and vinyl erasers. The entire story traced back to two key accidents: Priestley's rubber slip that revealed rubber's surprising ability to lift graphite, and Goodyear's overheated sample that transformed unstable rubber into an everyday essential. Together, these moments turned burned rubber and scientific curiosity into one of the most recognizable tools in writing and drawing. The humble eraser started as an unexpected discovery and became a universal companion to creativity, mathematics, engineering, and everyday writing. It shaped how people corrected mistakes, refined ideas, and communicated clearly on paper. And it all began with a simple accident that transformed a piece of rubber into a global necessity.